Okay, we started. Okay, so it's Monday, 11:23. We'll review the homework from chapter 6, 6, 7, and 8. And the lecture will be on 9 and 10 on slope of equations and system of linear equations. We'll do a little problem solving, and then we'll have our quiz. Before we do the quiz, we'll go over some of the things for the quiz too, okay? To try to sort of soften the blow a little bit here. So let's start out with homework. Any questions, any problems you want me to look at? Kathy, you said you had problems with that a little bit.
Yeah, I don't get any of it, so.
You don't get, that's not good. What particular part? Just the whole thing, or I mean?
I think it's the formulas. I just can't comprehend the formulas.
Let me stop sharing. Or this is for today, but go to week 8. Well, on the coordinate plane, this was the first thing we talked about last week during the Wednesday lecture, was just on the coordinate plane. And there's no formulas on this one, Kathy. You know, it's just a matter of getting your data points. When you have, you know, x, y coordinates, you always put the x first and then the y. Just.
Well, to me, that's a formula when you have an X and a Y or a J and.
Okay. Well, but on this, do you see my page, or can you see the coordinate? Am I sharing something with you? No. Okay. Okay, just a minute. Stop. We'll go. Right. Okay, so now can you see it?
No. Yes.
Yes. Okay. So the coordinate plane, right? We're just using an XY axis to define the coordinate plane, right? That's all we're doing here. And when we give a point on that plane, we always define it as the X value first and the Y value. So it's always X comma Y and with bracket or with parentheses around it, and that defines a point. That's all we're doing here on the coordinate plane. The origin is always at 0, 0. And to the left would always be negative. To the right would always be positive. Up would always be positive. Down would always be negative on the y-axis. I mean, so that's the definition of the coordinate plane, or they call it the Cartesian plane. And these are the point. The coordinates are like 2 and 3. It's just 2 in the x-axis, 3 in the y. So like this M would be the 2 and 3. So that's all that's about. It's not any more, you know, sophisticated than that. It's just defining the points on a plane. Okay, does that make sense to you?
Yeah.
Sort of. I mean, and then if we go on, we'll stop sharing that. We'll go on to the next page, and that's where it gets into some of the problems. Shoot, I'm gonna have to go. This is here. Yeah, on this one, you just had an exercise to define what those points were. Like point A, put it in terms of X and Y values. So A would be, the X value would be -4 and the Y would be 5. So it would be parenthesis -4, comma 5. That's how you write that for A. And that's all that was about here. They actually give you the coordinates and you're to put them on the graph, right? That's all we're doing there, okay? And this one, we're just trying to, which of the following pairs are on the line, okay? So you have to look at this and see if any of these on the line. And like number 11 wouldn't be the first one. It wouldn't be the second one. would be this one. No, that would be 1 and minus 2. Which of the following pairs are on the line? I don't see any. It's not that one.
Wouldn't it be D?
Oh, yeah, on the line. I'm sorry, I was looking at A and B. Yeah, it would be D, exactly. The minus 1 and 0. Okay, so that's all we were trying to do in that exercise. Okay, I'm going to go to the next page, because then it gets into some of the formulas, the real formulas, right? So stop sharing, share. Okay. So now we're graphing, okay? And there's a lot of detail on graphing because it's really important. That's what linear equations is all about, okay? Graphing, okay, on a coordinate plane. And it gives you an equation, graph the equation. This is in the slope-intercept form, so that when you have it, y is equal to x plus or minus something, that's the equation. The 3, or that 3 represents the slope of the line, and this value over here represents the intercept, where it intercepts on the y-axis. What are they doing here? Plot. So this 3x minus 4 is defined as this line right down here, where it crosses the y-axis at minus 4, and it has a slope of 3. In other words, it goes up 3 and over 1. That's what that
So
line. Yep.
the y equals 3x minus 4, that's what you would do to find the slope? Is that what you're saying?
The slope is the 3 in that.
Yeah.
In that
Oh,
case.
okay.
Yeah. By definition, it's y is equal to mx plus b, where m is the
Oh,
slope.
okay.
So that 3 is the slope. So that's a rise of 3 and over 1.
Yeah.
Okay. And that minus 4 value is the intercept, where it intercepts on the y-axis.
Okay.
So you take an equation with a y and an x in it, and you put it into this form. So then you can easily graph it. That's what we're trying to show here.
Okay.
Okay. Now there's example 2. They're saying point A of 5 and minus 6. Let me see. The point A lies on 5 and minus 6 on the coordinate plane. The graph of which the following equations pass through that point. Oh, so in this one, you're trying to see what point see if this point satisfies any of these 3 equations by putting x in for the x value. In other words, 5 in for x and putting in minus 6 for y. You plug those numbers in here and you see whether it's balanced, see whether it equals. So for the first one, if you put a minus, the y would be minus 6. That's equal to minus 5 times 5. So it'd be 25 plus 18. Well, that doesn't equal. Oh, wait. This is be minus 25. No, this doesn't equal that. You do the same thing with the second one. You put in a minus 6 for y. You put in minus 4 times, which is 20. Minus 20 plus 14 is minus 6. Minus 6 is equal to minus 6. So 2, that number 2 satisfies, that point is in this equation, just by substituting these values in here to see whether it's balanced. That's what we're doing there. Does that make sense?
So the -6 is the one that.
Well, that's the y value.
Yeah.
Okay.
Yeah.
And so you put -6 in for y, you put in 5 in for x, and you solve it to see which equation is true. That's what you're doing there. Okay.
Got it. Yep.
Okay. And then they go on. Yeah. In fact, they go on to explain it. That's what they've done down here. Yep. Option 2 is correct. That's just what I said. Okay. Because -6 is equal to minus 20 plus 14. Okay. Okay. So was this section hard for Jessica, Emily? Was this hard for you guys too, or not?
It
No,
wasn't for me.
the one that was hard was the slope and the the slope and equations. But
And
I think
so-
I think I got the hang of that one. Finally.
Okay,
The other two, yeah, I got it.
there was the next page on that. Okay, oh, on this particular section, remember we had a table and a graph. You put the X values in based on this equation. No, you randomly put in X values, and then you put that X value into this equation and solve for Y. Then you plot those points. That's what we're doing in these. Okay. You want me to go over one of them, or are we okay?
I'm okay with that one. I don't know if anybody else is.
Emily, are you okay with that?
Yeah, I am.
Okay. Kathy, do you want me to go over one of these?
Yeah, just pick one.
Okay, I will. I'm going to pick number 3. Okay. Minus 2 plus y is equal to minus x. Okay, just a minute. 1, 2. I'm writing this down. Okay, so I'm going to go to my sheet here. Stop. I want a spreadsheet right here. Okay, so I have a spreadsheet here, right? So just an Excel sheet, and I'm going to put that formula was minus 2 plus, right? Minus 2, if I can do it without having Excel have a hiccup on me. Was that equal to X or what? I can't.
Are you doing
I'm trying to do number 3. What was the, crud, I can't write it that way. What
example
was the
3?
original equation? Yeah. What did it say on top?
Minus 2 plus y equals negative x.
Thank you. Okay.
Mhm.
I can't do this in Excel, darn it, but I want to show it on a graph. Let me try something here. If I put a minus 2 plus y, do it like this, is equal to minus x. Okay, so this was the original equation, right? Forget about the brackets. I'm just doing this to satisfy Excel. So I have to put it in this form. Y is equal to mx plus b, okay? That's the slope-intercept form. I have to put this, so I have to change it. I get y by itself on one side. So it just means I have to add 2 to both sides to move that negative 2 over. When I do that, I get y is equal to 2 minus x, right? Oops, it's supposed to be minus x. So it looks like that, right? Everybody see that?
Yeah.
So then I have a table where y is equal to minus x plus 2. I just turned it around. And we want to put in values of 1, 2, and 3, I think it was, right? I'm just gonna really quick here. Okay, so this thing looks like this. So I put in 1 for x, for this negative x in here, I get y is equal to negative times 1, right? Plus 2. And the negative 1 plus 2 is just equal to a 1, right? So I put in 1 for y. I do the same thing with the second one. It's equal to a negative 2. And that's equal to 0, right? Everybody follow me so far? Kathy, does this make sense? I'm just taking this equation that I have in yellow up here, highlighted, right here, and I'm putting in values of x for 1, 2, and 3 into this equation, solving for y. That's all I'm doing. So I can get pairs. So I'll get an xy, an xy, and an xy when I'm done. The second one was that y was 0. The third one, y is equal to negative in this case, it's 3 plus 2. And that's equal to -1, right? So you okay so far? So now we just take this and graph it. And I'm going to use the neat little program in Excel to do that. It's very simple. Just hit insert, you go over to recommended graphs, you find one that makes sense, one that you want to look at. And in this case, it's a straight line I want to look at. So I'm going to click on that, say okay. I'll reduce it, make it a little smaller so we can see it. And so we end up with a thing like this. And then I'll do a trend line. So it's like that. So this is the graph of this equation, this y is equal to -2, negative x plus 2. So it's a negative, it's a 1-to-1 because it's the m value in here would be 1, but it's a -1. So it means the rise is really a negative rise. So it's down 1 and over 1, down 1. And that's what I have here. You go from this 1 down to 0, that's 1. If you go from 1 over to 2, that's 1. So it's down 1 and over 1. That's how you do that. Okay, so that's what you're to do on that. You're to fill in the table and then graph it. Okay. On the quiz, there will be a deal like one like this. Fill in the table, graph it. I give you the graph, I give you the table. You just have to put the numbers in. Okay. Does that make sense?
Yeah.
Okay. Okay, everyone's good. Okay, Kathy, you okay? Okay, that's what that was all about. Let's look on see what else is on that page. Okay, so that's what these 1, 2, 3, 4, that's what you were doing there. Completing the table and then graphing it, completing the table, graphing it by putting in these values of x into the particular equation, solving for y. Some of these I had to change this around to get y is equal to minus x plus 2, because you want to get it in that form. This one, you don't have to do anything. You just have to plug in the value of x in here and solve for y. This is the only one you had to really change the equation, okay, to put it in a different form. Okay, and the rest of these is just finding what point satisfies that equation by plugging in the x and y into this equation to see whether it's balanced or not, whether it's equal, whether it's true. Okay, that's all we're doing there. Okay, so let me go on to the next page, 368. Go to 368. Okay. I'm sharing 368. Okay. Now it's a little more information on the slope of a line, right? Where the slope is, it's defined as the rise over the run. So you've got a car here going up a hill. The slope of this car going up this hill would be the rise, how high it goes versus how far it goes over. Okay. It's the same thing as on a graph. How high it goes from one point to the next versus, or divided by how far it goes to the right. That's all we're doing. Some of these, it goes negative. When we go from this point to this point, we have to go down. We go down 6 and we go over 2. So it would be a -3 would be the slope. -6 divided by 2 is -3. So the slope would be -3 in this one. What would be the slope on the top one here? Anybody?
Where?
If you can see it. On this line right here. What would be the slope?
Would it be negative?
It's not negative, it's positive. I'm
Oh,
looking
it
at
should go up.
looking at this guy right here.
Yeah. It'd be a half.
Be a half. It'd be 1 over 2 because you go up 1 and you go to the right 2. So the rise over the run, the rise over the run. Always just remember that. That's sometimes the rise is negative. In this case, it's not negative, it's positive. It goes up, right? This one here, the rise is really negative. goes down 5 and or down 6 and over 2. This one goes up 1 and over 2. Okay. That's what the slope is defined as the rise over the run in all these linear equations. Okay. And then it gives the formula for the slope, and we went over this. It's the delta, the difference in the y values divided by the difference in the x values. That's the same thing as the rise over the run. It's the same thing. You take the second point minus the first point, second point minus the first point, and you divide one into the other, and you get that ratio, rise over run. Okay. And that's all they're doing here. You can, in other words, you're given 2 points, determine what the slope is. Again, you just put x1, y1, x2, y2. Plug it into this equation yourself for m. Okay. Okay. And go on to the next page. This is the last page on that section. Okay. And today is just a reinforcement of that. It's more of the same. Here's the slope equation up here, right? Y2 minus Y1. And the practicing it, you're showing, find the slope of each line. Again, it's just what we said. Take these 2 points on here, rise over run. So the rise is what on that graph? If you between these 2 points, what's the rise?
3. Let me go back to my homework.
Can you see what I'm looking at? A1.
Yeah.
What would that be?
My homework. God, what's A what?
I'm looking at A1 on page.
Yeah, I'm trying to
Okay.
I got the
The rise is what?
uh
Just go like between these 2 points here.
I got the slope is -4.
No, not number 1.
I'm
Positive.
wrong page.
I'm at practice 8, A1. It's on page 369. The -4 is number 2.
Ah,
So, but number 1 is not. What would be the slope of 1? Emily, do you know what the slope of 1 is?
oh, I got 1.
It's 1. It is 1.
Yeah,
Because
got
you
it.
go up 3 and you go over
Yeah, I
3.
was on the wrong
3
page.
divided by 3 is 1. Yeah. The second one is a -4 because you go down 4, or excuse me, -2. You go down 4 and over 2. Down 4 and over 2. So it's -4 divided by 2, which is -2. What about
Wrong
number?
page.
What?
That's
How about number 3? What's the slope of that one?
it is 0.
0, exactly. And what if it was a vertical line? What did we say the slope of that was?
Oh crap, I forget.
What was the slope of it? If it's a vertical?
Oh, undefined.
Undefined. Thank you. Very good.
Yeah.
It's undefined. Because it's an infinite number because you've got a number divided by 0. Anything divided by 0 is going to blow up. In other words, it'll get larger and larger and larger. So it's undefined. Okay. That's what that was all about. And here, all these pairs, we're just using that slope formula to determine what the slope is. Again, it's y2 minus y1 over x2 minus x1. Does that make sense?
Yeah.
That's what that's all about. Okay, stop sharing. And so if you had that one with, all right, let me see, why is this not doing it? So whatever I was looking at had slope of 3 and 5. I mean, excuse me, had point. first point was 3 and 5, and the second point was -1 and 2, and you're asked to find the slope. And the formula is m is equal to y2.
What question is that?
It's whatever page I was. It's on that last page. Here, all we're doing is there's a number of questions like that, and they're saying figure out what the slope is, and with giving 2 points, and that's what I'm doing. And so I just picked the first one.
Oh,
So
well, they're wrong on the points.
what do you mean?
I have -5, 3 and 1, 1.
Okay, negative.
Yeah.
-5 comma. Well, let me do it again.
-5, 3,
Okay.
1. The next coordinates are 1, 1.
Okay.
Yeah.
Okay. Let's do that. Then we'll use this. Forget this guy right here, but use this and plug it into this equation. Can't put my this program doesn't allow me to go back and edit. So if I make a mistake, I'm doomed. Can't change it. So I'm redoing that line. So that's your equation. So then you plug in the points. This is the x value. Just so you don't get confused. I get confused when I look at these things. That's why I like to take my time and put. So what I'm saying is that's x1, that's y1, that's x2, that's y2, right? And then I go ahead and plug them in. So I said y2 was 1, so it's 1 minus y1 is 3, so it's 1 minus 3, right? And that's all divided by x2, which is 1, minus a minus 5, right? So it looks like this. So it's minus 2 on top. This becomes a plus, so it becomes 6 on the bottom. This is down to 1/3. So that's your slope. That makes sense? Again, when you do this, make sure you identify these guys because it's easy to make a mistake. That's why I go ahead and put x1, y1, x2, y2. Okay? And just plug it into this formula. Boom, end up with the result. Okay? Kathy, does that make sense to you?
No.
No? Well,
Okay.
it's all based on this formula, right? You got it. That's what you've got to work with, okay? These are your points up here. Identify your points and then plug them into the formula. You know what I mean? Where I see a y2, I find what's y2 up here? Well, it's 1. That's why I put a 1 right there. And just go through and do the whole thing like that. Okay? That's what this is all based about. Even the stuff today is talking about this too. So you have to grasp this somehow. Just go over and over it so it clicks. It's really that, I mean, I say it's simple and it's not simple if you don't get it. I know it's not simple, but it's meant to be that easy. But if I graph this thing, it would look like this, a -5 over here and a +3. So that first point would be here. The second point would be 1 and 1 right here. Right? 1 and 1. I do a straight line through this. I could do a straight line. It would look like that. Well, it's got a rise, or it's really a negative rise of -2. It goes down 2 and it goes over 6. So this is 6. This is -2. Okay. That's all we're doing. We're just putting this thing on a graph, determining what the rise over run is, and that's what this formula does for you. Okay. If you can get this part, the rest of it should all fit together. Okay.
Was that the last chapter we did last week?
Yeah. Yep.
Oh, okay, that makes it. 'Cause I did 9, and that's what confused me.
Oh well. Don't be an overachiever.
Well, no, I thought that's one we did.
No, I know.
Oh, okay, then that's why it was hard to do
Oh,
it.
that's for today. Yeah.
Yeah.
Yeah,
Okay.
9 and 10 we're gonna do in a minute here.
That's
Okay.
funny.
Okay, so I'm gonna stop sharing this. Go back to our agenda, and that's where we're gonna be. Yeah, I see. Yeah, see, we did 6, 7, and 8 yesterday, or last Wednesday,
Okay.
right? So we're doing 9
Gotcha.
and 10. So we're in the slope of
All right.
equation. So we're still into slopes. That slope does not go away. Systems of linear equations, it just means two lines. That's all. And you find if they cross, and if they cross, that's the solution to the system of linear equations. That's all. So let's go into 9. Okay. It's just sort of more of what we did.
Yeah.
So okay, I gotta get the right agenda here. So we're going to week 9, 23rd. Okay. And stop sharing, and then we'll share right here. Okay. So now we're on slopes and equations. It's more of the same. Okay. Two different forms. The slope intercept form, that's the y is equal to mx plus b. That's the equation I always like to use to solve everything. Another one is called a point slope form. That's this form here. So you should write those two forms down. Write them down as notes. So the first is mx plus b. That's slope intercept. And the second is y minus y1 is equal to m times x minus x1. And that's called a point slope form. Point slope form. Okay. You see that second one, that's if I put the x on this side, that's what m is equal to delta y over delta x. That's how we got that equation. So write those two forms down, because on the problems on the next page, you're going to be asked to solve the linear equation by using those two different forms. Okay. Okay. And we'll go back to the first one. Slope intercept, y is equal to mx plus b. So if we have, on this example here, use the slope intercept to find the equation. We have the slope of 4, and we have 1 point. When we say slope intercept, intercept is where it crosses the y-axis. But in this particular case, it's it's a point. So we know the line passes through this point, -1 and -6. Okay. And it has a slope of 4. So if you go ahead and put these numbers, this data into this equation here, and I'll do it on the next page. I got to write this down first.
That's where you find the
We're
y
going to
intercept.
find that. We're going to find the y-intercept. What we're going to
Okay.
do. I'll show you. So it's 4, 1 and -6. Okay, so I'm going to stop sharing, and we're going to share. Go on to this. Okay. Clear this out. Okay, so what do we know? We know, back to our equation, y is equal to mx plus, that's equal, not equal, mx plus b. What do we know? We know m, it says m is equal to 4. We have 1 point, a -1 and a 6, right? So with this information and this equation, we got to solve for b, okay? That's the intercept. We got to solve for b, and then we can write the equation. So how do I do that? I put in 6 for y, and I put in -1 for x, and I'm just solving for it. So in this particular case, it looks like this. We've got 6 is equal to m was 4, it's given. The x value is -1, so it's like this, plus b, okay? So now you just solve for b. So now you've got 6 is equal to -4 plus b. Okay, I have to get b by itself on one side, so I add 4 to both sides, right? 6 plus 4 is equal to -4 plus 4 plus b, right? So this is 0, and so now I've got b on one side. Excuse me, and I've got 10 on the other side. So I've got 10 is equal to b. And that's the same thing as saying b is equal to 10. It's the same thing. So now I can take this 10, and I'm going to go ahead and put it up into that original equation here. I'm going to take this 10. I'm going to put it right up into here, okay? So now I'm going to rewrite that equation. So now I'm going to say y is equal to slope of 4x plus 10. Okay, that ends up being my new equation, okay, in the slope-intercept form, where this 10 is where it crosses the x-axis. So if you drew this thing, I'm just going to draw it sloppily, but I'll draw it. It just looks like this. Oops, gotta get the right pen here. Okay. So you've got a deal like this. And I know this 10 is where it crosses the y-axis. So this is up to 10. This is y, of course, this is x. This is 10 up here. That's where it crosses the y-axis. It's got a slope of 4, so it goes up 4 and over 1. So I'll just put it like this. So this line looks like this. Okay? Where it's got a rise of 4 and over 1, and it crosses the x-axis or the y-axis at 10. Does everybody understand that? That's what that equation gives you.
So at the 10, you add 4 over?
Well, yeah, because yeah, I mean, I have it right here.
Well, yeah, I'm just trying to see it on the graph, not by that.
It's right.
Yeah.
This is 10 right here,
There.
and this is 0. So this is up 10. Then I said, so that's where it crosses the y-axis. Then I says, it's got a slope of 4 plus 4, so you go up 4 and over 1. So it's a 4 to 1 slope and it crosses that y-axis right there at 10. Okay.
Okay.
Okay. Okay. So I'm going to stop sharing that. That's the y-intercept form. Okay. Now, the other form is the point slope form, which I usually never use this, quite frankly. I always like but it's another way of doing it, okay? But in some of your problems, will say use this form. So you can't fight City Hall. You gotta use them both, okay? So this one this is the formula. Y minus y1 is equal to m times x minus x1. The example's on the next page, so stop sharing that. Sharing. It looks like this. So that, can you see the example at the top of the page here? This was to use the slope intercept form. So in this particular one, you've got a slope of 2 and a point of 4 and 3. 4 and 3, and m is equal to 2. And you just put it, and then, so let me stop sharing, make sure I got it right. Okay, so back to this. Okay, got back to my whiteboard here. New, save. So this was the form of y minus y1 is equal to m times x minus x1. It looks like that. So in other words, if I've got a 1 point, a y, which would be the y1 and the x1, I could plug that into this equation. If I have m, it'll allow me to get what the it'll end up showing what the b-intercept is, and I'll show you what I mean by that. So in this particular case, we've got a point 4 and 3, right? And we've got m is equal to 2. So we put them into this equation. We say, okay, so it's y minus 3, right? I got a 3 there. Should be a 3. Is equal to m. M in this case is 2 times x minus x1 in this case is 4, right? So it looks like that. Everybody with me so far? All I've done is just put in the 4 and the 3 here. Okay. So now you put y minus 3 is equal to, and you just multiply 2 times x, this is 2x. 2 times minus 4 is minus 8. So now I've got this, right? But now I want to put this into the y is equal to mx plus b form. In other words, y by itself. So I have to add 3 to both sides, right? So y minus 3 plus 3 is equal to 2x minus 8 plus 3, right? Because I had to added 3 to both sides. So now I've got y is equal to 2x. I've got, this should be a plus. Darn it, I can't, oh, no, it's a minus. I can't change that. Sorry. This is it's a minus there. So it's minus 8 plus 3, so that's 5, right?
Mhm.
So I've got to redo this one over again too. So y, so now I've got y is equal to 2x plus, because that's was a minus 8, so it's plus 5, right? Does that make sense? If I hadn't missed, well, shoot, I was trying to put this thing around it. Sorry. I was just trying to show that y is equal to 2x plus 5. That's another, but by using this formula up here, by knowing a point and knowing a slope, I can figure out what the equation is, okay? The linear equation. Just put it in the terms of y is equal to mx plus b, okay? So I'm going to stop sharing that. I'm going to look at the homework. That's what this is down here. Use the slope-intercept form, y is equal to mx plus b, to find the equation of the line passes through the given point. So in this particular one, the slope-intercept form, you just put in that y value. In this particular one, you'd put in minus 2, the x you'd put in 1, and would be minus 4. And you get the equation by doing that. Do you want me to do one of these or?
Yeah.
Okay, let me do 3. Minus 4 and 2. M is equal to minus 1/3. Okay. So, boom. And we go here. Back to my whiteboard. Erase everything. Okay, so put our equation. Y is equal to mx plus b. Okay, it's the slope-intercept form of the equation. In this particular one, we have a point, and it's minus 4 and 2. And we also have a slope, m is equal to minus 1/3. Okay, this is number 3 we're looking at. So plug this into this equation. For y, we put 2. M, we put minus 1/3. For x, we put minus 4. Right? Oops, sorry, minus 4. We don't know what b is, but we're solving for b. Okay. So you see what I did? I plugged the y value in, the x value in to this equation, and when we're solving for b on this particular, we're solving for that y intercept. So now we've got 2 is equal to a minus times a minus is a plus. So it's 1/3 over, so it's 4/3 plus b. Okay. So now we're going to subtract 4/3 from both sides. Everybody with me so far?
Yeah.
Sorry, I got my numbers right. 4/3, yeah, okay. So we're going to subtract b, or 4/3, or 1 1/3 from both sides. That's what that is. So 1 1/3 minus, if I put 2 minus 1 1/3, it's 2/3. So b is equal to 2/3. So now I rewrite this thing and say y is equal to negative 1/3 x plus 2/3. Oops. So I'd leave it like that, or I could multiply everything by 3 and end up getting 2y. You can do it either way. Minus x plus 2. You see, this is the same thing as this. I just multiply everything by 3, so I get rid of the fraction part of it. Or excuse me, this should be 3y, not, yeah, sorry. Multiply by 3. So it'd be 3y is equal to minus x plus 2. So you could leave it like that or leave it like that and say, well, what does that look like in a graph form? So it's pretty simple. Just gonna rewrite it like this. So graph form looks like this. I just put this form right here. That's what I want to use. So it's going to cross at 2/3. If this is 1, it's going to cross right here, right? And it's got a negative slope of 1 to 3. So it's going to go down 1 and over 3. So if this was 1, it would, if this is 2/3, it would be down here and over 3. 1, 2, like this. So this thing would look like this. Okay. Oh, wait a minute, backwards. Let me see if I can get rid of that. I did. Okay. Wrong way. It's negative, so it's this way. So it's down, see, because it's negative. It's negative. So down 1 and over 3. Don't make a mistake that I almost made. It looks like this. Okay. So this is in the form. This is y is equal to negative 1/3 x plus 2/3. Okay. That's what this line is. Okay. Does that make sense to everybody? That's what we're doing on these. Okay. We're putting
Solving
in,
a bunch of things.
yeah, exactly. We're putting it in this form so we can go ahead and graph it. That's what you're doing. This is called the slope intercept form, where this is the slope, this is the intercept. Okay. So that's this equation right up here. If you know this and you know how to get the slope, you can solve all these. You know, it's just using algebra at that point, but you've got it. You have to understand this or write it down, memorize it to really understand it. Okay, questions on that? Okay, I'm going to stop sharing. And let me see what else is on that page. Yeah, that's all we're doing here. On this, okay, on C part, find the equation of the line that passed through the given points, write your answer. This you have to do a couple steps, okay? And we'll do one of these. Okay, we'll do number 7 for you. Okay. You've got 2 points here. You got -5 and 3. Then you've got 1 and 1. Okay. So I want to find the slope of this equation that passes through these 2 points. Okay. So how do you do that?
Which one are we doing? The number?
Numbers. Oh, good. I'll go back.
Okay.
Sorry.
My
Yeah,
bad.
number 7. No, number 7. Okay. Okay. So number 7. So here we are. Boom, boom. And we'll go here.
And
Okay, back to our infamous formula. Y is equal to mx plus b, right? And what are we given in this particular case? We're given 2 points, right? We're given a -5 and a 3. And the second point is a 1 and a 1, right? So that's what we're given. So we can call this point 1, this point 2. It doesn't matter. You can flip them around. It doesn't make any difference. But we're going to solve for m first. Okay? You're going to say m is equal to y2 minus y1. And that's in parentheses, all divided by x2 minus x1. You got it. These are the 2 equations you got to know. Okay? x1 minus x2. Okay? You got to know that. So if I say this is 1, this is 2, I'm going to say y2. I'm going to call this y2 over here. So I'm going to say 1 minus 1 minus 3, right? And that's going to be divided by x2, which is 1 minus a -5, right? Everybody with me at this point? This is a negative negative. So this, so I'm going to go on the second line here and say now m is equal to 1 minus 3 is what?
-2.
-2. What's 1 minus a -5?
1 minus,
What's a -1 times a -5 would be
it'll
a
be 5.
5, and 5 plus 1 is 6, right? So it look like that. I'm going to reduce this down, divide the numerator and denominator by 2, so I'll get -1 over 3. Okay, so that's my slope, right? I
Yep.
just plugged it into that. I just used those 2 points to find the slope. Now I have the slope. Now I can take one of these points and solve for b. Okay, that's the next step. So now I'm going to use this point because it's easier to use 1 and a 1. So I'm going to say 1 is equal to the slope of -1/3, right? 1 over 3 times 1, because I'm using this point up here, plus b. Everybody with me at this point?
Yeah.
Okay, so now we're just solving for, so now it becomes 1 is equal to -1/3 plus b, right? Now I have to move this 1/3 to the other side, so I have to add 1/3 to both sides. So left side, I'm going to have 1 plus 1/3 is equal to b. I'm going to add these together. 1/3, that's like 3/3 and 1/3, so it's 4/3. 4/3 is equal to b. Okay, or 1.3333. It's the same thing. So now I have my values, right? So now I've got what I need. I've got the b, right? And I determine what the slope is right here, right? So now I just plug them into this equation up here. This is the last step, okay? That's what I'm saying. You can do everything with this this equation and this equation and solve for all of these. So now the final deal is put y is equal to negative 1/3 times x plus 4/3. So the key on this, using these two equations, okay, right? Make sure you understand these two equations allows you to get this, okay? You can write that down. That's what it's all about. Okay. Questions on that? And it's just to make sure you did it right. Then you can go ahead and actually graph it, right?
Mhm.
Sloppily graph it like I've got here. And so if you had a -5 and a 3, so -5 plus 3 would be over here. -5 plus 3. And this is 1 and 1, so it would be here, right?
Oh, wow. Yeah.
Okay, so the slope
That's
ends up
cool.
being negative 1/3, goes down 1/3. The intercept is right here at 1 and 1/3, right down here. Okay. But anyway, by graphing it, you can see you did it right. You know, the key is this formula, plugging in the values and solving for the unknowns, right?
Mhm.
Okay, so if you can understand that, all this should make sense on this section. Okay. Questions on that part?
Okay.
Okay. Okay, I'm gonna go on to the next one. We're not done. We have a few things to go over here.
Yes. Oh, slope and unit rate.
Okay, more on slopes and unit rate. Okay. Again, slope is the rise over the run. Understand that. No matter what values you've got, all we're talking about here is cost of cost of gas. One data point, they got 3 gallons for $7.50. That's where the gallons is on the y-axis or x-axis. Cost is on the y-axis. The second point is $12.50 for 5 gallons. It's a linear equation. In other words, a straight line. You can take the slope of this line and you'll get what the unit rate is. In other words, how much per gallon. By unit rate, we mean divided where 1 is in the denominator. So if you took this, this particular case, you got from here to here, well, however you want to do it. You could do it that way. You could go from 3 gallons to 5 gallons. That would be 2 in the denominator. The numerator would be 750 into 1250. That's 5. 5 into 2 is 2.5. So 2.5. So it's $2.50 per gallon. That's what that graph shows you. Okay, that's what they got down here.
And you do that by doing the subtracting 5 from the 3
Yes. Yeah.
on that, and then
Yep.
the
And the
12.5
numerator is you're
7.5 do that
from
too.
12.5.
Yes, you
Again,
do then you do
yeah.
12.5 minus 7.5,
Exactly.
and
Divided by
then
5
get the
minus
difference.
3.
Okay.
Right? It's just a rise over run. That's all it is.
Yep.
It's the delta y over the delta x. Okay. Okay. So we're just reinforcing what we've done. I mean,
Yeah.
it's not new. It's just yeah.
Visually, it's different, so that's why I
Yeah.
like to know.
Yeah. Visually, it's different. You're right. Visually, it's different. Here's some more visually different ones too. Just so you get some more of this stuff,
Yeah.
whether you want it or not. Okay. Okay. Graph shows the cost of phones for the next 5 years on the market, of cost versus years. Okay, so again, it's just data points. So years on market. So if it's been on the market 1 year, it's $625. Yeah, if it's been on for 5 years, it's down to 405. Anyway, it's just showing it's a negative slope, right? I don't care what we want to call it, what's on these axes, but it's a negative slope. It's going down, right? Again, it's delta y, which is the rise over the delta x. In this case, the delta y is negative, and the rise is always positive. It's always to the right. Okay, that's all this. That's what we're doing here. This y2 minus y1s. Okay, it's all the same thing. Okay, that make any difference what graph you're looking at. Another example: Minnesota Construction Company orders limestone. Boom, 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 boom. Okay, person obviously knows there are 2.2 kilograms per pound of material. Decides to make a graph for reference when making purchases. Typically, you'll buy 100 kilogram fibers. Okay, time. What will the graph look like? And so he's got this graph of kilograms, amount he buys. Oh, he's converting kilograms to pounds is all we're doing, knowing that there's 2.2 pounds in a kilogram. That's the metric conversion of US pounds to kilograms. Okay, that's all. And so that's all this graph is showing. So it's supposedly helping him up when he goes to order. He can convert it quickly into pounds or pounds to kilograms. However, that's all that is. Does that make sense? Again, the slope is a constant slope, and it's 2.2 pounds per every kilogram. Okay, because it's a metric conversion. That's all. Okay. So, okay, we'll move. Next one. These things always take longer than what I think. I'm sorry. Okay, use the slope formula to find the rates that correspond to the number of these scenarios. Okay, so again, it's the same thing. If a company orders 150 pounds of fresh clams, serving 100 people, and 30 pounds of clams for a dinner party of 20 people, determine the standard number of clams per serving. So you can do the same thing on this one. You can do X, you can do two values, right? You've got an X and a Y value for two different data points. The first one is you've got 150 pounds and for 100 people. And the second one, you've got 30 pounds per 20 people. Okay, determine the standard unit of clams per serving. So you can take this 150 and 100 and 30 and 20. Do you understand what I mean? I mean, it's clams, and this is servings, clams and servings. So it ends up being 1.5 clams to per serving, right? Do you want me to show you that?
Sure.
Does that make sense? So we just sort of reinforce here what we're talking about. So it's like this. So in this particular case, we know two data points, 150 clams, 100 people, right? We also know 30 clams or 20 people, right? So that's what we know. So we can get the number of clams per person a couple different ways. We can get the slope. M is equal to, again, it's the same thing, x2, or excuse me, y2, y1. Or we just take we really don't have to do this. We just take the rate divided by x2 minus x1. In this particular case, if we said this was the second data point, we're going to negative over negative, but that's okay. If this is the x, this is the y, this is the x, this is the y. So in this particular case, it's going to be 20 minus 100. You know, just showing you can do these anyway. There's a number of ways of doing this stuff. Divided by, I said 20 minus 100, 30, 30 minus 150. See here, we've got negative numbers, but that's okay. So we've got negative 80 divided by negative 120, right?
Mm.
So you end up getting, so this is the same thing as 8 over 12. I'm just summarizing 8 over 12, which is equal to 2 over 3. So this is this particular case, it's the number of people per clam, right? So it's equal to 2 to 3 is equal to clams. No, people per clam. So we'd really want it the other way around. People per clam. But normally you'd just flip this around. You'd say, well, it's 3 over 2 clams per person. This makes more sense, right? Which is equal to 1.5. Does that make sense? That's all we're doing.
Yeah.
Okay.
Getting there.
Yeah. Okay. So let's look at. And all these are it's the same thing. Use the slope formula to find the rates. Yeah, they're not any harder than what that is.
Okay.
Okay.
So you can predict stuff.
Yeah, you can predict stuff. There you go. You
Got
predict. Yeah, you can, that's a good way of looking at it. You can predict stuff. Let's keep on going. But you can predict stuff. That's what you're doing here.
Pretty cool.
Yeah, well, that's why you use math. That's what it's all about. Right?
Universal language.
Yeah, it is. I mean, it really is. It just, yep. Again, here's more. Given the following graphs, determine the rates. Again, it's rise over run. So when they say 0, 0 here, they're talking about this this data point right here. So it's the rise. So it's 73 minus 0 over the run, which is 4, right? So it's 73 over 4. So it's a little less than 20. It's 4 into 73, right? That's all they're doing. Couldn't reverse. Okay. Oh, here, and then so they're putting, oh, so the answer is right here. The answer is C is 18.25 calls per hour. That would satisfy that, right? So in other words, you're just interpreting graphs, right, to determine what the unit rate is. That's what you're doing there. Another one, hours per to install 1 square foot of carpet. These are data points. And so hours per carpet. So we want to know, we want to assume this is linear. You can take this point and this point, or you can take this point and this point. You're going up from 40 to 100, or excuse me, no, you're going up from 1.5 to 2.25, and you're dividing it by 100 minus 40 or 60. See on that one, you're going to get, this is the Y value. So the hours is on this. Usually you'd put the time on this one, but anyway, they have it this way. So it's 2.25 minus 1.5, which is 0.75. So it's 0.75 divided by 100 minus 40, which is 60. So it's 0.75 divided by 60. Whatever that's equal to is one of these numbers down here. See what I did?
Yeah.
7, so it's 0.75. I can't do this right. 0.75 divided by 60.
So it's A, I think. A
It's
then,
0.0125.
yeah.
Yeah, it's A, exactly. That's all, okay? So that's how you do these, 275. 275.
Ooh.
Okay. Okay, 2 more pages. And we'll take a well-deserved break. Okay. Okay, linear equation. Okay, systems of equations. So this means more than one. Okay. Usually you're talking about 2 equations, 2 linear equations, and on a graph, normally they'll intersect somewhere. Excuse me, if they don't intersect, then they're parallel. But in this particular case, they'll intersect. When you say solve for a system of linear equations, you're determining where that intersection is. That's all you're doing. Okay. So I'm going to show you on 4, 2, 0. Well, what you do, okay, let me make this a little more. 5x plus y is equal to 7. Okay, look at these equations up here. Graph the equation and to find the solution. Okay, so what they're doing, they're just showing you how to graph it first, and then they're just looking at where it intersects. So I'm just going to show you this on using Desmos, which is what I like to use. So bear with me here. Of course, I don't have it. I gotta get to it just a sec here. Lord, just a minute. Okay, wait a minute. Desmos. Okay, so I have my Desmos. So I have 2 equations. One was 6x plus 3y is equal to 12, right? And the second one, I had 5x plus y is equal to 7. Oops, 5x plus y, that's why it looks weird. Okay, is equal to 7. So, okay, so you can't see my screen yet, right? So,
Right.
okay, but this minute, I'll get it for you in a minute. So I'm going to share, and then we're going to go over here. So now you should be able to see my decimal screen. Can you see it?
Oh, yeah. Whoa.
Okay, so what I have here is 2 equations. I've got the top 6x plus 3y is equal to 12. That's what the red line is. The other line is 5x plus y is equal to 7. That's what the blue line is. You see where they cross?
Mhm.
They cross where x for excuse me where y where x is equal to 1 and y is equal to 2. You take this x is equal to 1, y is equal to 2 into both of these equations, you'll see that it's satisfied, that it's balanced. That's the solution. That's the this system of equations, that would be the solution, okay? Where it crosses. Okay? So we've got 2 lines. If I'm gonna take this out, and if I had 2 lines like y is equal to 2x plus 4, and I had a second equation, y is equal to 2x plus 1, you see they're parallel, right? They never cross. There's no solution because they have the same slope. They just have a different y-intercept, right? One has 1, one has 4. Do you see that?
That's cool.
Really important to understand that part. Now, if I had changed 1 into like a negative, the second one here, boom, is a negative. So it's got the intercepts right here. So that value of minus 0.75 and 2.5 would satisfy both of those equations if you put those X and Y values into both equations, they would be satisfied. Okay. That's what we mean by a solution to a system of linear equations. There is no solution if they're parallel lines. But in most cases, you'll have an intersection. Okay. These are two straight lines. And you use this in economics and all kinds of things. You know, it's a practical thing that you do that you can use math for. Okay. Okay. Just understand that. This Desmos is really a neat, you know, if you have time, if you want to play around, it's free. You know, you just
Okay, yeah.
go to this site, desmos.com, and it'll say, do you want to log in, or do you want a username, or you just want to be a guest, or it doesn't make any difference. But you can get in there and play around with all kinds of things. And it even gets really cool because it allows you to, like here's parabolas, all kinds of
Oh, wow.
waves, unit, all kinds of things that you,
That's awesome.
yeah, it's very neat. You know, trig functions, just start to, you know, it helps you understand how you can convert an equation into a graph. This is a parabola, which is the x squared form, right? X squared plus x is equal to something. That's always a parabola. You can use this in physics and all kinds of things. Anyway, so the point is, this is a pretty neat program. You got some calculus stuff in here too. Okay. If it's two different functions, you can find out where they cross, blah, 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 just all kinds of things. Okay, so enough on that. But it is a pretty neat program. Okay, so, but that's what we're doing here, okay? We're drawing the line, and then we're seeing where it crosses. Where it crosses is this solution, right? That's what we're doing. So I'm going to go to the very last page here. Assume this is right, I hope. Okay. Okay, so here, what you have to do in this one is you have to graph these two lines. Y is equal to 3x minus 15. Graph x plus y is equal to 13. Find out where they cross, and that's your solution, right? They're saying make a t-chart to do that, and that's a table, XY table, right? To get like 3 points so you can draw your straight line, and then draw both straight lines, and then see where they cross, okay? Now, these, you're finding a solution for two equations by substitution. This is where you put one value in for the other value. I'll do one of these, okay? So you understand what I'm talking about. Minus y is equal to 22, 4x plus 2y is equal to 10. So I'm going to look at number 1, or excuse me, number 3. B3, okay, it's 7x minus y is equal to 22, 4x plus 2y is equal to 10. And I'm going to find the solution for the two equations by substitution. See how hard this is to do. I mean, not hard, but time consuming is what I mean. Okay, we're back to my whiteboard. Okay, so you've got 7x minus y is equal to 22. And then the second one is you've got 4x plus 2y is equal to 10. And so what we mean by substitution, we take one of these equations, like just take this one over here and put it in terms of y. So we've got 2y is equal to minus 4x plus 10. I just moved the 4x over to the right-hand side. So now I'm going to divide both sides by 2 so I can get y. So now I've got y is equal to minus 2x plus 5. Does everybody understand what I just did?
Mm-hmm.
Okay. So now I'm going to take this, put it in here, boom, for that y. Okay. That's what we mean by substitution. So it becomes 7x minus y, or minus, we're going to put in this, minus 2x plus 5, right, is equal to 22. So we okay so far? All I've done is I've taken this, put it into this equation right here. So now I've got 7x minus this value, minus 2x plus y is equal to 22. So now I'm going to take care of my negative negative. So now it's 7x plus 2x minus 5 is equal to 22. I'm doing this so I have, it's just x's over here. So I can collect my x's and solve for x. Okay, make sure I didn't make a mistake. Okay, so now I've got 9x now. 9x minus 5 is equal to 22. 22. Okay, so now I'm going to add 5 to both sides. So 9, oops, so below that, I'm going to put 9x is equal to 27. Well, this is nice because 9 will go into 27 3 times. So this means that x is equal to 3, right? So now I just take this 3, I substitute it back in for x, solve for y. I can do it in this equation, I can do it in this equation, doesn't matter. They'll both work.
Yeah.
Okay? So I'm going to put it back in this one.
Wow, that's awesome.
So that's all we're doing. So now it's 7 times 3, right? Minus y is equal to 22. Well, yeah. 7 times 3 minus y is equal to 22.
Nope. Get off.
Right? So now I've got 21. 21 minus y is equal to 22. So now I subtract 21 from both sides. I get negative y is equal to 1, right? I put negative 21 on both sides. So now I've got y is equal to negative 1. So here's my 2 points. My 2 points are x is equal to 3, y is equal to negative 1. That's the answer. That satisfies both of these equations. Okay? You could have graphed them and got the same thing. Okay, that's what that means.
Huh.
Does that make sense?
I love that. That's awesome.
But that's what substitution. Oh, shoot, sorry, I
Wow.
was trying to
Love it.
just show it on a just very quickly here. Good grief. Sorry about this. So one of these, y is equal to negative 22. So it's way down here, and it's in this. There's one line that goes like that. You know what I should do? No, I'm not going to worry about it. So one line goes like that. The other line is y is equal to minus 4, and it crosses at 10. It's like here. Yeah, it goes like this. Where they crossed is this y and this x value. If I had done this right, that's what it should be. But obviously I didn't do it right. But the point is that's how you do it. You graph these things and you'd see that it crosses it where x is equal to 3, y is equal to negative 1. Okay? But this is the substitution method. That's what that means, substitution. Any questions on that? Okay, let's take a 10-minute break and we'll get back and I'll explain the quiz. Okay? So thanks for bearing with me. Okay, 10 minutes. Okay, 9:30.
You're going to be able to email that again?
Yes, I'll do that right now. Thanks for reminding me. Yeah.
You.